Episode 13 of the World of FPGA podcast. You can run different kinds of applications or operating systems on a SoC. To get an overview, we will dive into embedded systems with connection to FPGA SoCs. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. In our last episode, we have talked about the workflow for an SoC development. And today, we will dive into embedded systems. And in my understanding, we have an embedded systems since we have an operating system. So we need to put all together now. Again, I'm very familiar with Xilinx Sync and other FPGAs from Xilinx, so I will use again as my template here, as my background, I'm using again Vivado and this time also Petalinux. FPGA development. The first part is quite equal to the last episode, because you have also here to create your logic design, and after creating your design and doing the synthesis and the implementation and the bitstream generation, you can export your hardware description file, and we are done with our FPGA. If you haven't heard the last episode, then just go back to the episode WFP013 and there you can hear what I'm talking about in FPGA development of an SoC. Before we start into the workflow, just do some words about Petalinux. I just will do a short introduction into Petalinux. Petalinux is maintained by Xilinx, and it is a combination of different tools. It is based on Yocto, which is an Linux distribution and also a generating system. And this toolbox we have in Petalinux have many automatic generation tools. It can generate and configure, for example, the kernel. It could configure other parts of your system. It is generating a working root file system and also filling the device tree for your Linux system. And if you have, for example, some Xe4 devices in your logic and it is connected to your processing system, then they will also be put into this device tree that you can have later access to your hardware you have created in your logic design. And yes, I know there are many other systems. For example, maybe you know Buildroot or other systems. They're also good. They can be used, but since I'm creating embedded Linux systems for Sync, I'm working with Petalinux and I'm quite fine. Yeah, if you have found all the little problems in this system, well, it's like in every development system. If you know what you're doing, then everything is fine. Well, and now let's go to the workflow. First, we have to export our hardware, and we will get our hardware export file. This is a file with the extension XSA, and it is more or less a zip file, and it's including system information, it's including the bitstream of your FPGA design, and also some initialization code for the processing system. With this file, this is the interface between Vivado and Vitis. It is also the interface between Vivado and Petalinux. Normally, there is no need to have a Vitis project and a Petalinux project. Most time you have the decision between bare metal application, then you go to Vitis, or you want to have an operating system, then you go to Petalinux. So the XSA file is the file you need to create one of these projects. In Petalinux, we will create a project and then importing the hardware. There are some command line commands. That's a good name. There are some commands for the command line to creating a project and then importing your hardware into this project. And after that, we can start the configuration of our system. And here we are using also tools from Petalinux. In the background, we have our Yocto system. And the configuration includes also the configuration of the file system, the root file system, and the image configuration. We can configure our kernel, for example, for additional drivers. Maybe we have components outside of the FPGA we want to connect to our embedded system. For example, an Ethernet PHY or an Ethernet MAC or an USB PHY or something like that. So if you have components in the outside of the processing system, in the outside of the FPGA, of the SoC, then you have to put this additional to the configuration. The system doesn't know which PHY you have built on your PCB. The system knows which part of the processing system is used and which X4 devices you have included into your logic, because this is transported via the XSA file from your FPGA development system to the Petalinux. We can also modify our root file system with additional tools and services and so on. And after that, we can do some additional modification of the system. Yocto is using here for some BB files. BB is the short form for BitBake. This is a system which downloads all the files you need for your root file system and for your configuration and so on. And you can define BitBake files to modify the system you want to get later on. For example, you can change mount points in the fstab file. You cannot access directly to a fstab file because this is could be overwritten if you want to recreate the project. But if you have the modification BB files, they'll be used later on in the process, and in this moment the fstab file will be changed in the manner you want to have. And after configuration and modification of the system, you can build it now. And this is done thanks to many scripts nearly automatically. The sources are getting downloaded and are saved for if you want to use them later on, and they get compiled. Also, the kernel get compiled and put all together, and the whole system is created automatically, and at the end we will have a bootable system. And here I want to make a short excursion into the booting of a system, because often the question came, how the system is doing it, that it is booting. So we just need something in our Sync, which is starting the booting process. And in the Sync we have something that is called boot ROM. This boot ROM is you can compare it maybe to a BIOS from a computer. So the Sync is always running the boot ROM code, and the boot ROM is searching depending on the boot mode configuration. We have the different boot modes for JTAG, for Flash, for SD card, and so on. And if you have configured the boot mode to SD card, then the boot ROM is searching on a SD card. Yes, the boot ROM can read VFAT partitions. So the first partition must be VFAT. And if you had on this VFAT partition a boot.ini, then the boot ROM is loading this boot.ini file. Or if you have a flash, then it's searching for a structure and then loading all the rest into the RAM. So the boot ROM is loading the FSBL into the internal memory and starts the FSBL. And the FSBL is searching, for example, for the U-boot. And the U-boot is the search boot stage here. Because the boot ROM is the stage 0, FSBL is the first stage bootloader, and U-boot is a second stage bootloader. And U-boot is then loading the kernel and other systems into the RAM. Well, and then quite normal, the Linux system is booting. So U-boot is very good to configure, very good to use, because on this stage you can access many things of the hardware. You can access, for example, Ethernet interface. You can access the MDIO to check if the Ethernet file is working. You can access USB. You can boot with U-boot also from USB. So if you have U-boot running, then you are you are quite fine, and then you can start debugging why the rest is not working. So U-boot is quite important, and I haven't mentioned it before, but the FSBL and the U-boot will also be automatically generated from the Petalinux workflow system. And you can have many different kind of systems. In the end, you can have a root file system which is writable. You can have a root file system which is read-only with an overlay file system, with file system running in the memory and so on. And I think for embedded systems, you should always have a read-only root file system. That's because I'm seen many systems you can just put on the switch and then it's starting the Linux and running. And if you are done, what are you doing? You switch it off. And if you have a writable root file system and you switch this off while maybe something is written, then you will get lost some data over time. So I think it is always a good idea to have a read-only root file system and a shadow overlay file system for log files and things like that. And this is can also be activated in the Petalinux. Yeah, and you have the choice. You can boot from flash, boot from SD card, boot from MMC memory. And if you have U-boot running, you can also boot from Ethernet or from USB. If you have, and I've mentioned it before, Xe4 devices in your programmable logic, you can access this also via Linux, because the device tree, so that's the name, because it's also filled into the device tree. And then for this, you have later on access through this system. And all the interfaces you have on the Sync are also usable. For example, the UART, the I2C interfaces, SPI interfaces, and so on. So there are many interfaces you can use later on. And then you have an embedded system with a powerful FPGA on its side. Think about video or some network things, and you can have high performance through your FPGA and flexibility through your Linux system. And with these ideas about embedded systems, it's the end of this episode for today. Further information and the newsletter you can find at world-of-fpga.com/WFP013. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye here and next time, your David Kirchner.